Okay, here we are back at the notebook. Something I want to reiterate is that when you're performing operations on NumPy, it's often done on an element by element basis where the operation is broadcasted across the array. To show a quick example, I will create an array, and then what I'm going to do is perform some operations on it, such as simple arithmetic. And as we've already discussed, I can add a single number to every element in the array, or I can divide by a number. I can do exponents, so square every number, and I can do a variety of these. So I can say plus 2, and then take that result and divide it by 100. So you can see here, we can perform element by element arithmetic on every element in the array. What you can also do is the same thing for two arrays of the same shape. So for example, I can take my array and add it to itself, and that'll perform an addition on an element by element basis. So you'll see here that essentially every number has been doubled since I'm just adding the two arrays together. Something to keep in mind is that when you're working with NumPy and you try to perform things like dividing by 0 or dividing by infinity, NumPy will actually not produce a full error. Instead, it will just produce a warning. So you can see here in our original array we have a 0. So if I try to say 1 divided by the array, I can't actually do 1 divided by 0. That doesn't really make any sense. But you'll notice, if I do this with NumPy, it will still give me an output. It will just also give me a warning saying, hey, I encountered something divided by 0. And instead of producing just an error, it'll put a placeholder there for infinity. We won't really encounter this issue throughout the course, but I do want you to be aware that in general, for dividing by 0, NumPy won't produce an error. And you'll notice here, if I were to say array divided by array, it'll show you again an invalid value encountered during true divide, and it'll replace it here with nan, since this is technically 0 divided by 0. So any number that's not 0 divided by 0, it'll put infinity, and then 0 divided by any number is going to put not a number, nan. So notice again, these are warnings, not full errors, since we still see an output. Okay. Now I also wanted to point out the fact that there are universal array functions. So there are a ton of universal array functions. You can check out the notebook for a link to a list of all of them. But basically, built into NumPy, if you just say NP, there's lots of built-in mathematical functions. So for example, if you wanted to take the square root of every number in an array, you could just say np.square-root or sqrt, pass in the array, and it will automatically take the square root. And you can do this for a wide variety of applications, such as taking the log of every number in the array. Again, notice we get an error here because the very first number is 0, so np.log of 0 is negative infinity, but it'll still work. And you can do this for trigonometric functions as well, like np-sine, pass in the array, and so on. You can check out the notebook for a link of all the universal array functions. These are just mathematical operations pre-built into NumPy for easy access for you to apply to every item in the array. Okay, now there's also summary statistics that you can call in an array. So you can call the sum of everything in the array by saying .sum, and you can call the mean, and we've already seen some of these like max and min and so on. So we can see sum and mean, but the last thing I want to show you is that there's actually an access logic to this. So when you're working with two-dimensional arrays, you may want just the mean of the columns or the mean of the rows, or the sum of the rows or the sum of the columns. To explore this effect, I'm going to create a new two-dimensional array called np.array, and here we'll go ahead and say 1, 2, 3, 4, comma, and then 5, 6, 7, 8, comma, and then 9, 10, 11, and 12. So here I have my two-dimensional array object. It's 3 by 4, and we can confirm this by checking the shape, 3 by 4. Now let's imagine if I were to say array 2D, and then say sum. Well, that's just going to sum up all the numbers. But let's imagine I wanted to sum up all the values of the rows, or all the values of the columns. In order to do that, I would need to say array2d.sum, and then you'll notice that if you do Shift-Tab here, there's an access argument. By default, access is none, but you can specify access as 0 or 1. By passing in access equal to 0, we're returning an array of sums along the vertical axis. Essentially, what's going to happen is access 0 that counts as rows. So we have 3 rows here, because remember at index 0, that's what the 0 stands for, the shape at index 0, that's the number of rows you have. So what we're saying here is give me the sum across the rows. So again, this is saying give me the sum across the rows. The key word being across. So it's going to perform this sum across the rows. So when you actually run that, you get back the sum of the individual columns. So 1, 5, 9, 2, 6, 10, 3, 7, 11, 4, 8, 12. Because we're performing the sum across axis equal to 0, or across the rows, this produces the sum of the columns, or the sum of all the values in the columns. So hopefully that makes sense. Again, you're performing this operation across the rows, so that here you have the rows, you perform the operation across the rows, and so that leads to the sum of all the columns. Likewise, you can perform the operation across the columns, so I can say axis equal to 1, and that returns back the sum of the row values, because I'm performing it across the columns. All right, so you can check out the various examples on axis logic in the notebook as well, but that's really it for NumPy operations. And as far as NumPy is concerned, we pretty much already know everything we need to continue on with the course and move on to pandas. Coming up next is going to be a quick set of exercises just to make sure that you fully understand your new skills. We'll see you at the next lecture where we go have a brief overview of the exercise questions.